Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic, math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the POIQ discussions on JEE Advanced paper. So today we have got a question from previous year's JEE Advanced paper 1. And this question is taken from the section 3. As you know, these questions you have to answer in non-negative integer number. You must try to answer all the questions in this section because you don't lose any mark even if you answer wrongly, and each question carries 4 marks. Okay, so let us try to solve this question. So this question says a closed container contains a homogeneous mixture of 2 moles of an ideal monatomic gas whose gamma is given as 5/3 and a 1 mole of an ideal diatomic gas whose gamma is given as 7/5. Here you know the gamma is the ratio of the specific heats at constant pressure to the constant volume of an ideal gas. So gamma is Cp/Cv. Cp is the molar specific heat at constant pressure and Cv is molar specific heat at constant volume. The question further says the gas mixture does a work of 66 joule when heated at constant pressure. The change in its internal energy is dash joule. So you have to fill this gap. So what are the informations given? We have been given 2 gases. We have been given 2 gases. One gas has been taken as 1 mole. So the first gas is taken as 1 mole. 2 moles. And the second gas is taken as 1 mole. Okay, first gas is monatomic and second gas is diatomic, and respective gammas are given, and the gas is performing work of 66 joule when it is heated at constant pressure. We have to find out internal energy. So there are few things to note here. You have to know how to write internal energy for a mixture gas. How do you write down work done here for a mixture gas? So these are the important point here. And if you have been given F, will you be able to find out internal energy? If you have been given F means degrees of freedom. Okay. So how do you get F from this gamma of each gas? So we know gamma is given as 1 plus 2 by F. So from here we can find out F, degrees of freedom for monatomic gas, or you can directly find out from the relation F is equal to 3n minus L. L is the number of constants. So from that formula also you can find out. Okay. So here for monatomic gas, you know, since you are going to write JEE Advanced, you know, for monatomic gas it is 3, and for diatomic gas it is going to be 5. Okay, you can use this formula to find out degrees of freedom. So once you get degrees of freedom, you have to write the total internal energy. Look, internal energy, change in internal energy is written as du is equal to Cv dt. Okay, Cv dt. Here both side I should write delta. So let me write delta T. Okay, so what is this Cv? This Cv is not for only one gas. This is a mixer gas, so you have to find out what is total Cv for the mixer gas. So look, you have to actually get, see, N1, C1 is specific heat at constant volume for the gas 1, and N2 C2 is molar specific heat for the gas 2 into delta T. So this is actually the expression for change in internal energy. Now we know what is C1, what is N1, what is N2, what is C2. C1 is actually Cv is actually du dt. Okay, du dt. Cv is du dt, that you know. Okay, so du, how you find out u? U actually is given as half into degrees of freedom into RT for 1 mole of gas. Okay, ideal gas, 1 mole, half into degrees of freedom into RT. So if we require to write here C1, what we should write? See, N1 is given already. I'll write 2 into C1. I'll write half into degrees of freedom is 3 into R into T. Sorry, this T will not be there because du dt is the Cp. Okay, similarly for the second gas I can write number of mole N2 is 1. Okay, degrees of freedom is, okay, half into degrees of freedom is 5 into R. So this is the expression for the internal energy. So you look, I can just find out here. This is 3R, so it will be actually 3R plus 5 by 2R into delta T, which is 11 by 2R into delta T. Okay, now let us go to the work done. See, we know for an ideal gas PV is equal to nRT. Here N is N1 plus N2. N1 plus N2 for, so these are the respective number of moles for the component gases in the mixture, and this is RT. So at constant pressure, how do we write work done? Work done can be written as PdV. Okay. So this I can write as, see, number of mole, total number of mole is always constant at any temperature. So we have got expression for this also. So I can write it here, just putting the values. N1 is equal to 2 and N2 is equal to 1. So this is 3R into delta T. Okay, now let me write it. du by W is equal to, so du is actually given as 11 by 2R into delta T, which we have already calculated recently. Sorry. So what we have calculated? 11 by 2 R delta T, that is delta U, divided by work done. Here we have got 3R delta T. Okay, so this delta T will cancel each other from numerator and denominator, and as a whole you get this. So R also will cancel out each other. So see, change in internal energy divided by work done is this much. So now you look, we have been given the work done by the mixer gas, right? And that is how much? That is actually 66 joule. So if I put it here, 66 joule in place of work done, then this is in the unit of joule now. So this will be, see this, I can do the division with 11. So this 11 into 11 will give you 121 joule. Okay, look the question. So joule unit is given, so you have to just put the value here. So what is the value here? 121. So this is the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for IIT JEE coaching? Parents, do you want your kids to achieve top scores in IIT JEE? India's leading online NEET coaching 100% success IIT JEE. At TeenEinstein, we focus on IIT JEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com